Imagine traveling through space for 330 million light-years and finding almost nothing. No galaxies spinning in cosmic ballet. No stellar nurseries birthing new stars. No clusters of matter painting the darkness with light. Just an incomprehensible emptiness that shouldn't exist. Welcome to the Boötes Void. A cosmic mystery so vast and so empty that it challenges everything we thought we knew about how the universe builds itself. They call it the Great Nothing. The supervoid. And some scientists whisper it might be evidence of something far stranger than we ever imagined. Hello, space enthusiasts! Today, we're venturing into one of the universe's most perplexing mysteries. A region of space so empty, so inexplicably barren, that its very existence keeps cosmologists awake at night. The Boötes Void isn't just empty space. It's a cosmic anomaly that spans approximately 330 million light-years in diameter. To put that in perspective, you could fit over 2,000 Milky Way galaxies side by side across this void, except you couldn't because there's almost nothing there. But here's what makes this truly terrifying. According to our best models of cosmic evolution, this void shouldn't exist. Not at this size. Not with this level of emptiness. Not in a universe that's only 13.8 billion years old. Our story begins in 1981, when astronomer Robert Kirshner and his team at the University of Michigan were conducting what seemed like a routine survey of galaxies. They were mapping the cosmic web, that beautiful, intricate structure of galaxy filaments that stretches across the universe like neurons in a cosmic brain. But then they found it. Or rather, they didn't find it. In the direction of the constellation Boötes, the herdsmen, their instruments detected silence. Where they expected to find hundreds, perhaps thousands of galaxies, they found a handful, maybe 60 galaxies scattered. Across a region that should contain roughly 2,000. It was like expecting to find a bustling city and discovering a desert with a few lonely outposts. Kirshner later described the discovery as like looking at a map of the United States and finding that between New York and San Francisco, there were only a couple of gas stations. The team double-checked their equipment. They verified their calculations. The void was real, and it was enormous. The discovery sent shockwaves through the astronomical community. Here was a structure, or rather, a lack of structure, that seemed to violate the cosmological principle, the foundational assumption that the universe is roughly uniform when viewed at large scales. To understand why the Boötes Void is so extraordinary, we need to understand the architecture of our universe. The cosmos isn't randomly scattered with galaxies like salt on a table. Instead, it's organized into what we call the cosmic web, a vast network of dark matter and gas filaments, along which galaxies cluster like dewdrops on a spider's web. Between these filaments are voids, regions of relatively empty space. Think of it like Swiss cheese, where the cheese represents galaxy clusters and filaments, and the holes are voids. These voids are normal. In fact, they make up about 80% of the universe's volume. But here's the thing. Typical voids are about 30 to 150 million light-years across. The Boötes Void is at least 330 million light-years in diameter. Some measurements suggest it could be as large as 400 million light-years. It's not just bigger, it's categorically different. It's a supervoid, and according to computer simulations of cosmic evolution, a void this large shouldn't have had time to form in the current age of the universe. Let's take an impossible journey into the Boötes Void. As we leave the dense galactic neighborhoods behind and enter this cosmic desert, the first thing we'd notice is the darkness. The few galaxies that do exist here, roughly 60 have been catalogued, are arranged in a peculiar way. They don't scatter randomly through the void, but instead form a tube-like structure, almost like a tunnel of galaxies running through the emptiness. This void galaxy tube is one of the void's most puzzling features. Why would the few galaxies present arrange themselves this way? Some astronomers suggest this tube might be the remnant of an ancient cosmic structure, a fossil from the early universe that somehow survived while everything around it didn't. The galaxies within the void are different too. Many show signs of recent collision or interaction, suggesting they've been moving through this emptiness, occasionally encountering one another in the vast darkness. They're like ships passing in an endless night, sometimes close enough to exchange gravitational handshakes that leave them forever changed. If you lived on a planet in one of these void galaxies, the night sky would be profoundly different. Where we see the dusty band of the Milky Way and can observe neighboring galaxies with modest telescopes, void dwellers would see darkness. The nearest galaxy neighbor might be 50 million light-years away. The universe would appear far lonelier, far emptier. So how did this cosmic cavity form? Scientists have proposed several theories, each more fascinating than the last. Theory 1, the bubble junction. The leading theory suggests the Boötes Void formed from the merger of smaller voids. In the early universe, quantum fluctuations created regions of slightly different density. Over billions of years, gravity pulled matter from less dense regions into denser ones, creating the first small voids. The Boötes Void might be where several of these smaller voids merged, like soap bubbles combining into one massive bubble. Computer simulations support this idea, but they struggle to produce voids quite this large, this empty, this soon in cosmic history. It's possible, but it requires a perfect storm of conditions. Theory 2, the dark energy accelerator. Some cosmologists propose that the Boötes Void might be a region where dark energy, that mysterious force causing the universe's expansion to accelerate, is slightly stronger. This could have pushed matter outward faster than in surrounding regions, creating an ever-expanding bubble of emptiness. This theory is controversial because it suggests the universe might not be as uniform as we assume. If dark energy varies from place to place, it could revolutionize our understanding of cosmology. Theory 3, the primordial origin. Perhaps most intriguingly, some scientists suggest the Boötes Void might be a remnant from the universe's first moments. During cosmic inflation, that period of exponential expansion in the universe's first fraction of a second, quantum fluctuations were stretched to cosmic scales. The Boötes Void might represent an unusually large negative fluctuation, a cosmic valley that never filled in. Not everyone agrees the Boötes Void is as empty or unusual as initially thought. In recent years, improved galaxy surveys have detected more galaxies within the void than originally counted. Some astronomers argue that what we call the Boötes Void might actually be several smaller voids that appear connected from our perspective, like looking at a mountain range edge-on and seeing it as a single wall. Dr. Greg Aldering from Lawrence Berkeley National Laboratory has argued that the void might be 50% less empty than original estimates suggested. It's still a significant underdensity, he notes, but perhaps not the cosmic impossibility it first appeared to be. Yet others, like Dr. Istvan Shapudi from the University of Hawaii, maintain that even with revised galaxy counts, the Boötes Void remains one of the largest confirmed structures in the universe and a significant challenge to our cosmological models. Where science finds mystery, imagination flourishes. The Boötes Void has inspired some of the most exotic theories in cosmology. Some scientists have half-seriously suggested the void might be evidence of Type 3 civilizations. On the Kardashev scale, civilizations so advanced they've surrounded entire galaxies with Dyson spheres to harvest all available energy, making those galaxies invisible to us. It's an extremely unlikely explanation, but the fact that serious scientists even mention it shows how puzzling the void remains. Others have proposed the void might be evidence of parallel universes bumping into ours, creating a region where matter was pushed aside by the collision. While this sounds like science fiction, the theory of eternal inflation does predict that our universe might occasionally interact with others in a vast multiverse. There's even speculation that the Boötes Void might be related to the infamous cold spot in the cosmic microwave background, another cosmic anomaly that might represent a supervoid between us and the edge of the observable universe. The existence of the Boötes Void forces us to confront uncomfortable questions about our universe. If structures this large and empty can form, what else might be out there? How many of our assumptions about cosmic uniformity might be wrong? The void also impacts our understanding of galaxy evolution. Galaxies in dense regions evolve differently than isolated galaxies. affected by gravitational interactions, mergers, and the flow of intergalactic gas. The few galaxies within the Boötes Void offer a unique laboratory for studying galaxy evolution in isolation. Furthermore, supervoids like Boötes affect how light travels through the universe. Through a phenomenon called the Integrated Sachs-Wolfe effect, photons from the cosmic microwave background lose energy crossing these vast empty regions, leaving subtle signatures we can detect. These signatures help us map the universe's large-scale structure and test theories about dark energy. Today, astronomers continue probing the Boötes Void with increasingly sophisticated instruments. The Sloan Digital Sky Survey has provided the most detailed maps yet of the void's structure, revealing complexities invisible to earlier surveys. The upcoming Vera Rubin Observatory, with its ability to survey the entire visible sky every few nights, promises to revolutionize our understanding of cosmic voids. It might detect faint dwarf galaxies within the Boötes Void that have escaped detection, or confirm that the void is truly as empty as it appears. Radio telescopes are searching for clouds of neutral hydrogen that might lurk unseen in the void, matter that hasn't formed stars and therefore doesn't shine. The square-kilometer array, when completed, will be sensitive enough to detect even tiny wisps of gas in the cosmic darkness. Scientists are also using the Boötes Void as a testing ground for modified theories of gravity. If gravity works differently at very large scales, as some alternatives to dark matter propose, supervoids like Boötes might reveal these differences. The Boötes Void reminds us that the universe still holds profound mysteries. In an age where we can detect gravitational waves from colliding black holes billions of light years away, where we've mapped the cosmic web across billions of years of cosmic time, this enormous emptiness stands as a humbling reminder of how much we don't know. Is it a cosmic accident? A region where random chance created extraordinary emptiness? Is it evidence that our universe is stranger than our current theories suggest? Or is it, as some propose, a window into physics beyond our current understanding? A place where dark energy, quantum fluctuations, or even other universes have left their mark? Whatever the answer, the Boötes Void serves as a powerful reminder that absence can be as meaningful as presence. In its emptiness, we find questions that push the boundaries of cosmology. In its darkness, we see the shadows of cosmic forces we're only beginning to understand. The next time you look up at the night sky, remember that between those points of light lie vast oceans of darkness, and in one particular direction, toward the constellation Boötes, lies a darkness so deep and vast that it challenges our very understanding of existence. What do you think created the Boötes Void? Is it a natural result of cosmic evolution, or evidence of something more exotic? Could there be even larger voids waiting to be discovered in parts of the universe we haven't fully mapped? Share your theories in the comments below. Let's explore this cosmic mystery together. If you enjoyed this journey into the cosmic unknown, please like this video and subscribe for more explorations of the universe's greatest mysteries. Hit the notification bell to join us next week when we investigate another cosmic enigma that keeps scientists awake at night. Until then, keep looking up, keep questioning, and remember, sometimes the most profound mysteries hide not in what we can see, but in what we can't.